Or what you think if you just go by the letters. Emily, Miles, you cool?
Yeah.
Okay. Have I said anything wrong in the last 30 seconds?
No.
Okay. Now, so dead easy. You just learn all those fellas upside down. Just while I'm revising this, is there a third way that we do trigonometry super fast? Of course there is. We use a calculator. Okay. There's no cosec or sec buttons on the calculator. You just do cos and sine and turn them upside down. Right? What's another way we do trigonometry super fast? Triangles? What do you mean?
The special triangles.
The special triangles are just this. Yeah, if you learn this table off by heart, you don't need the special triangles. You only need the special triangles if you don't know that table off by heart. Right? Anything else? What about sine of 510? How would you handle that? Huh? Elvira?
Go around in the circle. Could you do the cast one and find out like the equivalent and like in horizontal?
Okay, I think what you're saying is, forgive me for colloquializing it, but all big angles can basically be reduced to small angles if you swing around the circle and compare them to the x-axis. Is that what you're saying? So 500. Let's do 210 first, right? So start at 0. 90, 180 to get to 210. You squeeze on an extra 30. Yeah. So what I'm telling you is sine 210, cos 210, tan 210. That is therefore the same as sine 30, cos 30, tan 30. In other words, there's this wonderful thing that big angles can be done using small angles. Emily, do you remember the technical term for the small angles? They're called the auxiliary angles, which is from the Latin meaning auxilium, which just means help. Yeah? And obviously they help you because smaller angles are easier to deal with bigger angles, because the smaller angles are in here. Lizzie, that looks like it's surprising you.
Oh no, I just didn't know where to.
Yeah, but you know how big angles can be done with smaller angles? Yeah? That's not quite true. These things are not quite true. What do you need to do? You need to pay attention to whether they're positive or negative, and that's what the cast diagram is for. The cast diagram is solely a little device for telling you whether you should put positives or negatives on these things. In other words, whether it's as easy as it looks. So is sine 210 really the same as sine 30? I don't think it is, because when you're down here, you've clearly got a negative y coordinate, so that definitely has a negative on it. If you're over here, you've also clearly got a negative x coordinates. That totally needs a negative on it if you want to genuinely get the answer. And what about that one? Well, tan is sine over cos, so that'll be a negative divided by a negative, so that would be a positive. But gee, that's a brain hustle what I just said. So therefore some clever cat said that all three of sine, cos and tan are positive if your fat dot is around here. Sine is positive, tan and cos are negative if you're around here, if your fat dot's around here. Tan is positive with sine and cos negative if you're around here, and if you're around here, cos is positive. Okay? So, this is a massive generalization. I mean, it's true, big angles can be done with small angles. They come out literally the same decimal. You just need to decide whether to put a negative on. That's what the cast diagram is for. The cast diagram, I don't really think of it as this. I think of cast as just a device for positives or negatives. If your fat dot lands there, or there, you do not need the cast diagram. You don't need C, A, S or T, because you just ask yourself, how high is that? 1. You ask yourself, how high is that? Negative 1. You don't need some punk to tell you whether it's positive 1 or negative 1. You just physically look at it. Is it up high or down low? This one, just look. Is it over to the right or over to the left? You don't need a funky little thing to tell you. Does that make sense? Okay. So we've got sec theta is all the answers for cos upside down. We have sine theta is all the answers for cosec is all the answers for sine upside down. And finally there's cot theta, which is all the answers for tan upside down. Okay? So, as an example, what would cot of 315 be? Well, what's the answer for what's tan 315? And then when you report it to me, just turn it upside down. So how are we going to do it? Is this an instant one? Emma? Sort of?
Yeah.
How?
When you can reduce it down to smaller angles.
Yeah, which smaller angle? What's the auxiliary angle here? 45. Okay, so let's just check that. Start there. 90, 180, 270. 360 is going too far. Come back 45. And yeah, you'll be at 315. Yeah? So, therefore, cot 315 is the same as cot 45. But I need to put a negative on, don't I? Because I'm down here where only cos is positive. So, what is my answer for tan 45? It's 1. So my answer is negative 1 over 1, which is negative 1. We good with that? Now, before I just get you to do some practice on this, I just want to tell you one little subtlety. Doing tan fast is slower than doing sine and cos fast, because sine is just how high you are, what the y-coordinate is. Cos is just how far to the left or right you are, in other words, the x-coordinate. Tan, you have to work out sine and cos and then divide one by the other, unless it's just straight out of the table. Therefore, people often recommend doing this. Now, do you dig that? If cot is the tan answer upside down, do you dig that? Do you endorse that? Any reservations? It's pretty cool. It's a time saver. Don't work out sine divided by cos and then turn the answer upside down. Just work out cos divided by sine. It saves time, right? We good with that? Chloe, you good with that?
Yeah.
There's a big but.